June 6, 1944. Just after sunrise. The cliffs and beaches of Normandy are shaking under the roar of naval guns. The air is thick with smoke, sand, and the metallic smell of burning steel. American troops push forward across Omaha Beach, trying to break through one of the most fortified coastlines the world has ever seen. Between the explosions, between the screams and the rattling of machine guns, something unusual appears on the battlefield, something no Allied soldier has seen before. At first, it looks like a toy. A small tracked vehicle, barely half a meter tall, creeping out of a collapsed German bunker. No turret. No crew. No markings. Just a low, compact shape grinding across the rubble on thin metal tracks. Is that a kid's tank? A soldier shouts, half laughing, half confused. But the laughter lasts only a second. The strange machine keeps moving, straight toward them. It doesn't fire. It doesn't stop. It simply advances with a slow, steady determination that feels unnerving in a place where everything else is chaos. A gunner takes aim and fires. Bullets spark off its casing, but it continues forward. Another man tries to hit it with a grenade, too late. For a brief moment, there's silence. Then a blinding flash. A violent shockwave slams the soldiers to the ground. The sand erupts. The air rips apart. The machine is gone, nothing left but a crater large enough to swallow a jeep. The men scramble for cover, shouting over one another, trying to understand what just happened. It wasn't a landmine. It wasn't a vehicle. It was something else entirely. A crawling bomb. A remote-controlled demolition drone built by the German army, one of the earliest true battlefield robots in history. Its name was Goliath. But despite the biblical reference, this machine was no giant. It was small, almost insignificant in size, but packed with enough explosives to destroy a tank, collapse a bunker, or wipe out an entire infantry squad with a single detonation. And on this morning, as the Allies tried to break through Hitler's Atlantic Wall, the German defenders unleashed these machines in the hope of stopping the invasion. To many who faced them, they were terrifying. To the engineers who designed them, they were the future. To historians, they represent one of the earliest attempts to use robotics in war. But where did this strange weapon come from? Who built it? Why did Germany invest so much in a miniature tracked vehicle wired with explosives? And did the Goliath truly change the course of battles, or was it just another failed experiment of a desperate regime? To understand the full story, we need to step back from the beaches of Normandy and return to the beginning, before the invasion, before the panic, before the battlefield smoke revealed this unsettling new weapon. Because the origins of the Goliath lie not in the chaos of 1944, but in a quieter place, a design workshop, hundreds of kilometers away, where German engineers were dreaming of a weapon that could save lives by sacrificing itself. A weapon that would walk, quietly, patiently, straight into the enemy's defenses. A weapon Germany hoped would change the rules of war. To understand how the Goliath was born, we need to step back from the beaches of Normandy and return to a far quieter setting, the engineering rooms of pre-war Germany. The story begins in the early 1940s, long before the Allies ever set foot in France. At the time, the German High Command was facing a technical problem they had struggled with for years: how to destroy enemy fortifications without sacrificing their own men. Germany remembered the horrors of World War I all too well. Concrete bunkers, barbed wire, machine gun nests that chewed entire battalions apart. Armies had thrown thousands of soldiers into hopeless assaults because no other option existed. In the new era of mechanized warfare, the German army wanted something different, something that could crawl into an enemy stronghold and explode without sending young soldiers to their deaths. The idea of a remotely controlled demolition vehicle began forming long before the Goliath itself. German military planners envisioned a small, expendable machine packed with explosives, capable of sneaking into trenches, under tanks, or into bunkers. It would be the equivalent of a precision-guided bomb on tracks. A weapon that removes the human from the most dangerous part of the job. The breakthrough came from an unexpected source, a Polish company. Before the war, the German army captured a unique vehicle during the invasion of Poland, a small, wire-guided demolition tractor built by the firm Telefunken Elektrogerät. It was primitive, slow, and unreliable, but the Germans immediately recognized its potential. They disassembled it, studied every bolt and wire, and realized they could build something better, smaller, faster, and more powerful. The task was handed to Borgward, a major German automotive manufacturer with experience in building compact tracked vehicles. Their engineers worked under intense pressure, sketching designs for a machine that had to be small enough to be transported easily, powerful enough to carry a significant explosive charge, simple enough to mass produce, reliable enough to operate by remote control under battlefield conditions. The result was unlike anything seen before: a narrow, low-profile tracked vehicle just over a meter long, weighing around 220 pounds, 100 kilograms, carrying up to 100 pounds, 45 kilograms, of explosives in a sealed belly compartment. It was not armored. It was not meant to survive. Its only job was to reach the target and detonate. Control was simple: a spool of cable, up to 650 meters long, connected the machine to a remote control box. By sending electrical impulses through the wires, the operator could steer the Goliath left, right, forward, or trigger the explosive charge. It was, in essence, a suicide drone decades before the word drone would exist. But designing the Goliath was only the first step. German commanders quickly realized that this tiny explosive vehicle could have multiple roles: clearing minefields, blowing up bunkers, collapsing anti-tank obstacles, even attacking enemy armor from angles traditional weapons couldn't reach. By 1942, the German High Command gave the order: full production. Factories across Germany began turning out Goliaths by the thousands. Borgward improved the design repeatedly, refining the tracks, improving the motor, and experimenting with electric and gasoline versions. But the big question remained: would this new robot bomb make a difference on the battlefield? The answer would come soon, on the Eastern Front, in Italy, and finally on the beaches of Normandy, where Allied soldiers would face the strange crawling machine for the first time. The Goliath might have been small, but engineering it was anything but simple. Germany was attempting something no army had ever perfected before: a fully remote-controlled, tracked demolition vehicle that could operate under fire, across mud, rubble, wire, and cratered terrain. Turning that idea into a functioning battlefield weapon required a mixture of innovation, compromise, and sheer wartime necessity. A compact machine with a single purpose. At its core, the Goliath was designed around one brutal requirement: deliver explosives to the target, no matter the terrain, no matter the conditions. Everything else came second. Engineers made the machine extremely low to the ground. Its silhouette was barely taller than a man's knee, allowing it to crawl beneath obstacles or approach undetected. The hull was narrow and box-like, built from thin steel plates. There was no armor to speak of. Adding protection would make it too slow and too expensive. It was expected to die in the blast anyway. The tracked system was based on miniature versions of Germany's early war armored vehicles, but simplified to the extreme. Lightweight, flexible tracks gave the Goliath surprising off-road performance for its size. Engineers tested it across sand, wet soil, broken masonry, and even shallow water to ensure that the tiny vehicle could reach its target without bogging down. Electric or gasoline? The two competing versions. Because the original Polish design was electric, Borgward engineers first produced an electrically powered Goliath. This early model, known as the SD KFZ-302, used two electric motors and carried large battery packs inside the hull. It had two major advantages. It was quiet, almost silent. It produced no exhaust plume that could reveal its path. But electric power had a fatal flaw. Batteries of the 1940s gave the machine extremely limited range. Operators found that the Goliath often ran out of power before reaching distant targets. Charging batteries in frontline conditions was another nightmare. So the engineers made a second version, the SD KFZ-303, powered by a tiny 12-horsepower gasoline engine. This model was noisier, easier to spot, and left a faint exhaust trail, but it could travel much farther and at slightly higher speeds. The gasoline version would become the most widely produced and the one seen most often in combat. The control system. A drone on a wire. Remote control technology in the 1940s was primitive, but German engineers found a clever workaround. A triple-strand control cable. This thin wire, unspooled as the Goliath advanced, carried signals that allowed the operator to steer left, steer right, accelerate forward, and, when needed, trigger the detonation charge. The cable could be up to 650 meters long, giving the operator a safe distance from the explosion. The control box itself was relatively simple: 3 switches, a joystick-like lever, and an arming mechanism. It wasn't elegant. It wasn't modern. But it worked. The explosive charge, a mobile bomb. The entire front half of the Goliath contained a sealed TNT charge weighing between 60 and 100 kilograms, 130 to 220 pounds. When the operator flipped the final switch, the vehicle simply became a moving demolition charge. Engineers designed the hull to split cleanly in the blast, maximizing damage to bunkers, tank hulls, or anti-personnel obstacles. Mass production, quantity over perfection. Germany built more than 7,500 Goliaths during the war, far more than most people realize. Borgwood's factories streamlined production by using stamped metal parts, simplified engines, and quick-release components. Goliaths were packed into crates, stacked into trucks, and shipped to the Eastern Front, Italy, and eventually France. They were issued to engineer battalions, panzer grenadier units, fortress defense troops, and elite formations like the Panzer Division. But despite their careful engineering, one weakness remained: the cable. If cut by artillery, bullets, or debris, the Goliath instantly died. This flaw would define their fate on the battlefield, but before that, the Germans put them into action, testing them in some of the fiercest battles of the war. It was a cold morning on the outskirts of a shattered French town in 1944 when the Goliath made its first true appearance on the battlefield. Smoke hung low over the ruined buildings, and the distant sounds of artillery echoed through the streets. The Allies had no idea what was coming. From the shadows of a German defensive line, the tiny, tracked machine began to move forward. At first, it looked almost comical, its small frame skittering across rubble-strewn ground, but that impression vanished in an instant. Soldiers who glimpsed it up close saw a deadly intent in every inch of its design. The Goliath's operators had spent months preparing for this moment. Each cable was checked, every motor calibrated, and every explosive charge meticulously secured. The mission was simple in theory: send the machine forward to clear obstacles and destroy fortified positions without risking German lives. In practice, it was far more complex. The terrain was unpredictable, and the Allies were alert, firing at any movement. But the Goliath had one advantage: its size and unexpected appearance allowed it to slip into areas that were otherwise too dangerous for infantry or tanks. As it crawled toward its first target, the Allied troops reacted with confusion and fear. The tiny machine, barely 3 meters long, carried a payload of explosives that could level walls and destroy vehicles in seconds. It moved silently at first, the electric motor almost invisible, until the moment it reached its objective. Then, with a sudden, violent eruption, the explosion tore through the building, scattering debris and sending shockwaves across the street. Soldiers dove for cover, stunned by the destructive power of such a small device. This first successful strike was more than just a tactical achievement, it was a psychological blow. Allied forces now faced an enemy capable of sending death into the battlefield without risking a single human life. Commanders had to rethink their strategies, reinforcing positions and searching for new ways to counter these machines. Meanwhile, German engineers celebrated the Goliath's potential. Though still limited by range, terrain, and vulnerability to gunfire, it had proven itself capable of reshaping the fight, introducing an entirely new dimension of fear and destruction. The first blood spilled by the Goliath marked the beginning of a new chapter in mechanized warfare. Soldiers on both sides would come to recognize its danger, and though many would be destroyed before reaching their targets, the very presence of these machines slowed attacks, forced cautious advances, and left a lasting impression on the survivors. The battlefield had become a place where even the smallest machines could wield enormous power, and the Goliath had stepped onto that stage with a statement that would not soon be forgotten. After its first strikes, the Goliath quickly became a symbol of both innovation and dread on the battlefield. German engineers refined their approach, carefully selecting missions where the machine's small size and explosive payload could have the greatest impact. Every deployment required precision. Operators had to navigate rubble-strewn streets, shattered bunkers, and obstacles left by retreating forces. A single miscalculation could render the machine useless, yet the potential payoff was enormous. When the Goliath reached its target, its explosion could demolish fortifications, crush light vehicles, and clear paths that would have taken infantry hours to overcome. The Allies soon realized they were facing a new type of threat. Unlike traditional artillery or tanks, the Goliath moved with unpredictable stealth, silently approaching from directions no one expected. Infantry soldiers who spotted one often hesitated, uncertain how to respond to a machine that was part tank, part demolition device, and entirely relentless. Its presence forced them to adopt extreme caution, slow their advances, and divert resources to hunt down the tiny machines before they could strike. In this way, even a Goliath that never reached its target still influenced the course of battle, shaping decisions and draining energy from the front lines. Despite its mechanical nature, the Goliath introduced a very human element of fear. Soldiers described the eerie whir of its electric motor, the crawling motion of its tracks, and the sudden, devastating explosion that seemed to appear from nowhere. The psychological impact was immediate. Uncertainty and tension ran high, and the mere rumor of a Goliath in the area could paralyze troops momentarily. The Germans exploited this effect intentionally, sending multiple machines forward in coordinated strikes, overwhelming defenders and maximizing the terror factor. However, the limitations of the Goliath were as clear as its power. Mud, sand, and debris could easily trap it. Enemy gunfire could destroy it in moments. Its reliance on cable guidance meant that operators had to remain within a dangerous range, often exposed to counterattack. Yet for all its flaws, the Goliath represented a profound tactical advantage. It allowed the Germans to attempt daring demolitions and take risks that would have been impossible with conventional forces. Each mission, successful or not, reinforced the lesson that even a small, expendable machine could have a disproportionately large impact on the battlefield. By the end of its initial deployments, the Goliath had proven itself as more than just a weapon of destruction. It was a psychological tool, a tactical equalizer, and a harbinger of the mechanized future of warfare. Its explosions reshaped towns, its presence reshaped strategies, and its legacy would linger in the minds of those who survived to tell the story. The first blood of the Goliath had been shed, and the battlefield would never view small machines the same way again. While the Goliath had demonstrated its potential to terrify and destroy, its operations were far from simple. Every mission highlighted the fragile balance between mechanical ingenuity and battlefield reality. The tiny tracked machines, though seemingly unstoppable, were vulnerable to the harsh conditions of war. Streets littered with rubble, trenches filled with debris, mud, sand, and even the slightest incline could halt a Goliath in its tracks. Engineers quickly realized that no amount of planning could completely negate the influence of the environment, and each deployment carried the ever-present risk of failure. The operators themselves faced enormous pressure. Guiding the machine along a cable, often under enemy fire, required precision, nerves of steel, and absolute concentration. One misjudged turn, one snagged cable, or a sudden obstacle could spell disaster, not just for the mission, but for the crew who risked exposure on the battlefield. They became a silent extension of the Goliath's mechanical body, their lives tethered to its fragile tracks, their success measured by inches and seconds. The Goliath's electric motor, while quiet and lethal, had its own limitations. It offered the advantage of stealth, but its speed was slow, and any interruption, whether from terrain, debris, or direct enemy fire, could render the mission moot. Allied soldiers quickly learned to counter it with small arms fire, improvised barriers, and creative tactics, forcing German operators to constantly adapt. The combination of human ingenuity and environmental unpredictability meant that every deployment was a high-stakes gamble, a delicate dance between success and catastrophic failure. Yet, even with its limitations, the Goliath maintained a psychological advantage far beyond its mechanical strength. The whir of its electric motor, the sight of its crawling tracks, and the sudden, explosive devastation it caused created uncertainty and fear. Infantry units had to pause, rethink, and approach the battlefield with extreme caution, often slowing their own offensive operations. In effect, the Goliath succeeded as much through fear and distraction as through physical destruction. By confronting these challenges head-on, the engineers and operators of the Goliath refined its use, learning to exploit its strengths while mitigating weaknesses. Each mission, successful or failed, contributed to a growing understanding of mechanized warfare, revealing both the promise and peril of remote-controlled explosives. It became clear that even small, fragile machines could leave a massive mark on the battlefield, shaping tactics, decisions, and morale in ways previously unimagined. The true power of the Goliath was not only measured in explosives or destruction, it was in the fear it instilled. Soldiers on the front lines quickly discovered that the machine's impact extended far beyond shattered walls and twisted metal. Its mere presence transformed a familiar battlefield into a place of uncertainty and heightened danger. Every shadow, every small movement in the rubble could be interpreted as a looming threat, forcing infantry to react with caution and hesitation. This constant tension drained energy, slowed advances, and disrupted coordinated attacks, giving the Germans a tactical advantage disproportionate to the Goliath's size. Reports from Allied units described the eerie sensation of hearing a faint whir, followed by a creeping realization that a machine, barely larger than a small cart, was advancing methodically toward their position. The Goliath's electric motor produced a near-silent hum, an almost imperceptible sound that contrasted with the chaos of artillery and gunfire. By the time soldiers identified the source, it was often too late to prevent destruction. The unpredictability of its approach amplified anxiety, as troops were forced to consider threats they had never faced before, machines without pilots, moving relentlessly, capable of striking anywhere. Commanders soon understood that the psychological effect could be as potent as the physical damage. Defensive strategies were altered, with additional troops diverted to watch for these tiny machines. Barricades, improvised obstacles, and rapid response tactics were developed, not always to destroy the Goliath, but to slow it long enough to protect vital positions. Even Goliaths that never reached their targets contributed to this pervasive sense of dread, forcing Allied forces to expend energy, resources, and attention in ways that indirectly strengthened the German defensive line. At the same time, German operators realized the dual nature of their invention. The success of a mission was not purely in the explosive outcome, but also in how the machine altered the behavior of enemy soldiers. Each operation served as a live experiment in psychological warfare, teaching valuable lessons about fear, perception, and the strategic deployment of mechanized threats. Through this lens, the Goliath became more than a remote-controlled demolition device. It became a symbol of terror, a quiet but relentless presence capable of influencing decisions, shaping engagements, and turning ordinary men into cautious, anxious defenders. By the end of these initial campaigns, the Goliath had earned a reputation that far exceeded its mechanical capabilities. Survivors of encounters spoke of it in hushed tones, sharing stories of its creeping advance and sudden, devastating impact. It had proven that in modern warfare, the mind could be as much a battlefield as the ground itself, and that even the smallest machine could command a terrifying authority over human psychology. As the Goliath continued to wreak havoc across European battlefields, the Allies realized that ignoring it was no longer an option. Soldiers and engineers alike faced a new challenge: how to neutralize a threat that was small, silent, and seemingly unstoppable. The tiny, remote-controlled machines forced a re-evaluation of defensive tactics, as conventional strategies proved inadequate against an enemy that could move unseen and detonate at will. Improvised solutions became necessary, and innovation quickly became a key factor in survival. Infantry units began to develop early warning methods, scanning the streets, rubble, and open fields for the faint whir of the electric motor. Trenches were reinforced, obstacles placed, and machine gun teams trained specifically to target the small, low-profile machines before they could reach key positions. Snipers and light weapons crews adapted, aiming not for the machine itself but for the operator's exposed cable connections, attempting to sever the link and render the Goliath useless. Every engagement became a test of speed, perception, and creativity, as the Allies sought to outsmart a weapon designed to exploit fear and surprise. Engineers also worked tirelessly to understand the Goliath's design and limitations. Through captured units and battlefield analysis, they identified weaknesses in the machine's tracks, its electric motor, and its guidance system. Countermeasures were developed, from simple obstacles and barricades to more complex traps intended to disable the device before it could reach its target. Coordination between frontline troops and technical teams became essential, blending intelligence with brute force in an effort to neutralize a tool that thrived on chaos and uncertainty. Despite these efforts, the Goliath remained a formidable psychological weapon. Its presence forced soldiers to divert attention, slow their advances, and consider threats that did not exist before. Even a failed deployment left a mark, a reminder that the enemy had embraced innovation and was willing to exploit it relentlessly. Every attempt to counter the Goliath taught lessons not only about the machine itself but also about modern warfare, the importance of adaptability, and the growing role of mechanized and remote-controlled devices in shaping strategy. By the end of the initial encounters, it became clear that defeating the Goliath required more than firepower, it demanded ingenuity, anticipation, and nerves of steel. The Allies' evolving responses marked the beginning of a technological duel, a battle of wits and adaptation where every move, every countermeasure, and every successful disruption contributed to the gradual erosion of the Goliath's effectiveness. Even in defeat, the machine left its mark, reshaping how armies approached urban warfare, demolition tactics, and the emerging reality of mechanized combat. By the end of the war, the Goliath had become more than just a weapon. It had become a lesson in innovation, adaptability, and the evolving nature of combat. Its use revealed the immense potential of remote-controlled machinery, long before modern drones and robotic systems would dominate the battlefield. Despite its size and limitations, the Goliath left an indelible mark on both strategy and military thinking. Engineers studied its design, noting the combination of compact size, simple mechanics, and remote operation as a pioneering approach. The concept of a small, expendable, yet lethal machine influenced post-war military projects and demonstrated that technological ingenuity could amplify the psychological and tactical impact of a relatively modest device. For decades, the lessons of the Goliath would inform experiments in automation, demolition, and battlefield psychology, proving that even the smallest innovations could ripple outward to create major strategic consequences. The psychological influence of the Goliath remained perhaps its most enduring legacy. Soldiers recounted tales of its sudden, creeping advance, and these stories traveled far beyond the immediate battlefield. It taught the importance of anticipating the enemy's unconventional tools and highlighted that terror, when strategically applied, could become as effective as physical firepower. Urban combat, demolition operations, and defensive planning would forever carry the imprint of these tiny, terrifying machines. In reflecting on the Goliath, one sees a bridge between the past and the future, a demonstration that innovation need not be grand in scale to be monumental in effect. It was not the size of the weapon that mattered, but its ingenuity, precision, and the fear it instilled. The legacy of the Goliath endures in modern military strategy, showing that imagination, when paired with engineering, can transform the landscape of warfare and leave lessons that outlast even the conflict in which they first appeared. The story of the Goliath did not end with the war's conclusion. Its presence on battlefields from Normandy to the occupied territories left a mark not only in wrecked fortifications but in the minds of those who survived its approach. The demolition drones proved that even a small, mechanized tool could alter the course of combat by combining lethality with psychological intimidation. The Goliath demonstrated that ingenuity could overcome brute force, showing that the clever application of technology could achieve outsized effects against larger, better-equipped forces. Operationally, the Goliath influenced tactics and strategy long after its introduction. Infantry units, engineers, and commanders learned to anticipate unconventional threats, altering the way defenses were constructed and coordinated. Even when captured or neutralized, every deployment of the Goliath forced a reaction, diverting troops and resources and shaping the pace of battles. Its use highlighted the growing importance of mechanization, remote operation, and psychological warfare, elements that would dominate future conflicts in ways the small, tracked mind could never have imagined. The human element was equally significant. German operators, often young soldiers trained to control the device remotely, became part of a new type of warfare, one that required precision, patience, and nerves of steel. On the Allied side, soldiers faced challenges that tested adaptability, courage, and the capacity to innovate under pressure. The Goliath, in its small but formidable way, became a teacher to both sides of the conflict. Ultimately, the legacy of the Goliath is a testament to the evolution of warfare. It reminds us that every innovation, no matter how modest in size, has the potential to redefine combat. Small machines can create big effects, and psychological impact can rival physical destruction in its ability to shape outcomes. The demolition drones of World War II, tiny yet terrifying, occupy a unique place in history, proof that technological creativity, when applied strategically, can echo far beyond the battlefield and leave lessons that endure long after the guns have fallen silent.